Alright, so we're taking notes on antiderivatives. And antiderivatives are what takes you back to the original equation. For example, if I know that f of x is sine of x, and f prime of x, that means that's cosine of x. Whenever I do 0 to pi of cosine of x, then I'm trying to look for the original equation, because the fundamental theorem of calculus says that if I know the original, which in this case is sine of x, that I can evaluate it at 0 and pi, and I'll get my answer. So sine of pi minus sine of 0, which is 0 minus 0. So the reason we're taking notes on antiderivatives is so that we can figure out what these are. Because so far, on all the problems you've seen, we've been given the original. So now, we're going to try to figure out how we find the original without having to just know it. Alright, so if I tell you that I want you to take the integral of 5 dx, and there's no numbers there, that just means find the antiderivative. Well, the antiderivative of 5 dx is what you would take the derivative of to get 5. So that would be 5x. Think about it. The derivative of 5x is 5, so that's why this equals 5x. Now, it actually could equal 5x plus 3. It could equal 5x minus 10. It really could equal 5x plus anything as long as it's just a number. So we call this 5x plus c. And so anytime that you're trying to find these, you should have a plus c on the answer, because when you're taking the derivative of those things, it doesn't matter what c is, you still get 5. So our first formula is that if I want to take the integral of k dx, where k is a number, see x right there tells me x is a variable, so that tells me that k is a number, then the antiderivative is kx plus c. Alright, now let's talk about what happens when we have something else, like maybe x to the third dx. I think you know that if I'm trying to find the antiderivative, that the answer is going to be something with x to the fourth, because it has to be a power more. But the derivative of x to the fourth is 4x to the third. Well, see, I'm wanting the derivative to be x to the third, so I need to get rid of that 4. So what I'm going to have to do is I'm going to have to divide that by 4. And there's still a plus c. If I had the integral of x to the 10th, well, I know it's x to the 11th. Keep in mind the derivative of x to the 11th is 11x to the 10th. I gotta get rid of this 11 just like I had to get rid of that 4. So if you divide it by 11, then when you find the derivative, then you're dividing by that 11, which makes it go away. So it's x to the 11th over 11 plus c. So that leads us to a formula. If you have the integral of x to any power, then the antiderivative, you add 1 to the power, and you divide by it. Instead of multiplying it by like you do on the derivative, you divide by it. And you have plus c. Now, in this case, you got to be really, really careful, because n doesn't equal -1. Let me show you why. If you have the integral of x to the -1 dx, that's the same as the integral of 1 over x. Well, what do you take the derivative of to get 1 over x? Well, there's another formula. That's ln of x, and I think you just know that. But if I would have done that formula on this problem right here, that would have been x to the -1 plus 1 over -1 plus 1, which would be x to the 0 over 0. Can't do that, because 0 is on the bottom. So that's why we have this other formula. And we know that the derivative of ln of x is 1 over x, so that's why that works. Okay, here's another formula. If I'm going to take the integral of e to the x, well, that's still e to the x, because the derivative of e to the x is e to the x, so the antiderivative is still e to the x. Okay, let's talk about sine and cosine. The integral of sine of x, well, we know that the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine x. So the antiderivative, we know it's a cosine. So think about the derivative of cosine. The derivative of cosine is negative sine. But we have sine is what we're trying to find, so we've got to put a negative on this. So it's kind of backwards from the way the derivative works. If I have the, and here's another formula, by the way. If I have the integral of cosine of x dx, well, it's sine x, because the derivative of sine is cosine. Alright, so let's do a problem where we're using a lot of the formulas. Alright, so these are just polynomials, so we're going to use that first formula. It'll be add 1 to the power, so x to the 4th over 4. Okay, add 1 to the power here, to the 3rd, over 3. And then that'll be just 5x, and then we just leave it that way. Here's another one. If there's a number in front of sine or cosine or e to the x, or like any of those others, then we do it the same way that you always have when you did the derivatives. The antiderivative of 3 sine x would be 3 cosine of x, but I've got to have that negative to make sure the derivative works out. And then the derivative of 4e to the x is 4e to the x. That was 12. Okay, here's 13. Another formula. What do we take the derivative of that gives us 1 over cosine squared? Well, that would be tangent. You won't really need this next one a lot, but I want to go ahead and show it to you just in case. By the way, I think where I put that d to the x shouldn't have been there. That doesn't look right. It should have been cosine squared of x, and then dx is kind of outside of it. Just to remind you that x is the variable. Anyway, integral of a to the x dx. Alright, the derivative of a to the x is ln of a times a to the x. Well, the antiderivative is a to the x over ln of a, because when I take the derivative of that, the ln of a's would cancel to give me back what I started with, which was a to the x. Like I said, I don't think you'll have to use that one very often, but there it is just in case. Alright, here's another one let's look at. Alright, just like we did with the derivative, first thing I would do is I'd rewrite that as 2x to the 1/2, and then 3x to the negative 2. And now I can do my rule. I'm going to add 1 to the 1/2, so that would be x to the 3/2. 2 still there. I'm going to divide by 3/2. Alright, if I have 1 divided by 3/2, that's the same as flipping it. So when I divide by 3/2, that just means I'm going to multiply by 2/3. And then here, if I add 1 to the power, I get negative 1, and then I divide by negative 1. The only time you flip it is if you get a fraction. And so if I simplify that, I get 4/3 x to the 3/2 minus 3x to the negative 1 plus c. Alright, the integral of x minus 1 over x squared. This one's a little different, but we kind of do the same thing that we did with derivatives before we learned the quotient rule. We separate it, x over x squared minus 1 over x squared, and then rewrite that, 1 over x minus x to the negative 2. I didn't write that as x to the negative 1 because I know that the antiderivative is ln of x. Write the next one, but add 1 to the power, that's negative 1. There's a negative and divide by negative, so you end up with natural log of x plus x to the negative 1. Now, very quickly, those first things we were doing are called antiderivatives. And the reason we're doing them is so that we can solve definite integrals. So let me just show you an example. Let's say that I have the integral of 2x squared minus 3. And I want to go from 1 to 3. So this is very, very similar to what we were just doing. The problem is they've got numbers there. So what I do is I work this part out first. The antiderivative of 2x squared, that would be x to the third over 2. And then, over 3. Because that's x to the third. And then the antiderivative of 3 would be 3x. And then the way I do it is I put this little line here to tell me to evaluate everything at 3 and then at 1, and then we subtract. So we're going to plug in the 3. You plug it into both of them. Minus, and then you plug in the 1. Plug in a 1, that's just 2/3. Plug in the 1 there, so minus 3. And then we work that out. So I get, let's see, one of these 3's will cancel. So it'd be 2 times 9, which is 18. 3 times 3 is 9. Alright, 2/3 minus 3 would be negative 7/3, and that minus makes it plus 7/3. You're welcome to leave it like that. They would give you credit for that on the exam. They actually would probably give you credit for this right here if you didn't mark it out. So that was the whole reason for us finding the antiderivatives, is so that we can solve those kinds of problems. Alright, I'm going to leave you with 3 problems that I want you to try and come to school with them worked out as best as you can. So number 18 is 4x squared minus 3x. Just find the antiderivative. 2 over x dx. Find the antiderivative. Gotta change that color to make it pretty. The integral of 4 cosine of x minus 1 over x to the third dx.